Okay, so today we're going to talk about a concept called percent composition. It's part of Unit 6. So far, we have talked about finding the molar mass of compounds, and that's how much 1 mole of a compound weighs when you add up the individual masses of the elements in a compound. And then we have talked about how to convert moles to grams and grams to moles. We go from moles to grams, we multiply by the molar mass. When we go from grams to moles, we divide the grams that are given in the problem divided by the molar mass to find to go from grams to moles. So now we're going to talk about percent composition and what exactly it is. And so percent composition, the definition would be the percent by mass of each element in a compound. So basically what we're doing is we're going to take the part of something divided by the whole and then multiply it by 100 to get a percent. So if we look at this, we can find the percent, of anything. If you took a classroom where you had, let's say, if you had 5 boys and you had 7 girls, if we wanted to find the percent of the boys, we would need the total. We'd have to add these up to find the 12 would be the total. If we were finding the percent boys, we would take 5, the part of boys divided by the total, 12, multiplied by 100 to get a percent, and we would have the percentage of the class that is boys. If we were finding the girls, we'd take the part of the girls, which is 7, divided by 12, multiplied by 100, and you would get the percent of the class that's girls. Now, the way you can check percent composition is once you get your percents, if you add them up, they should equal 100 or something very close to it, like 99 or maybe 101 or in between there, and that's the way you can check your work to make sure your percents are right. So, percent by mass, we bring in the kind of our equation for that is going to be the mass of the element in a compound divided by the molar mass, which is the total mass of the compound, and then you multiply that by 100, and that would give you your percent of each element in the compound. Now, where this is important is this can be used to, if you had a chemical that you didn't know what it was, you could find the percent, what elements were made up in. You could do certain tests to find the percent of each element in that compound, and from that data, you could come up with the formula for that compound. So that's one way it's used. It's also used for like finding the percent of different things that are in the air. If you're looking at air pollution or what's making up your air quality or the percent of certain elements that's in the soil. So it's used for different things. Now the steps we're going to use, I'm going to have to get rid of this. So our steps is going to be to find the molar mass of the compound. We've already done that. You know, you should know how to do that by now. Then you're going to take the individual masses of each element, divide it by the molar mass, then multiply by 100 to get the percent of each element of the compound. We're going to round these to 2 decimal places. Our molar masses we round to 2 decimal places, so we're going to keep everything consistent when we do this. Now, when you check some work, my answers might be to 1 decimal place, but you know, round yours to 2, and as long as you have something close, you might be a few tenths different than an answer, but that's fine as long as you're something that's really, really close. So our first example problem, it says determine the percent composition of each element of aluminum chloride. And we have to, you know, I give you the formula, AlCl3. So we want to find the percent of aluminum in this compound and the percent of the compound that is made up of chlorine. So first thing we do, our first step is to find the molar mass. So we have each element, we have aluminum that makes this up, and we have chlorine. So aluminum, we have 1 aluminum atom. We're going to multiply that by the molar mass of aluminum. Chlorine, we have 3 of those atoms. We're going to multiply it by the molar mass of chlorine. So I need my periodic table, and I look and I find aluminum. Aluminum is 26.982, which your periodic table should be to 2 decimal places, so use that mass, but I'm going to round this to 2 decimal places. It'd be 26.98. And then chlorine, the molar mass of chlorine is 35.453, so that'd be 35.45. So then I need my calculator. One times 26.98 is going to be 26.98, and then 3 times 35.45 equals 106.35. I add those up to get the total molar mass. And that equals, if I did my math right, 133.33. Now I'm going to take each individual mass and divide it by the total. So for aluminum, that would be 26.98 divided by the total, which is 133.33. And then once I do that, I multiply that number by 100 to get a percent. And then for chlorine, its mass, total mass, those 3 chlorine atoms was 106.35. I divide it by the total molar mass, which is 133.33. Multiply it by 100 to get a percent. So first for aluminum, 26.98 divided by 133.33. That equals, then I multiply that by 100. And that's just going to move the decimal places over 2 places. I'm going to round this to 2 decimal places, the percent. So that would be 20.24. And that's percent aluminum. And then chlorine is going to be 106.35 divided by the total, 133.33. That equals, then multiplied by 100 to get a percent. That equals 79.76. Percent chlorine. So those are my answers. What I can do is add these up to see if they equal 100 to check my work. So that'd be 20.24 plus 79.76, and that equals exactly 100. Now, if I add these up and they equal 99 point something, then that's close enough. I probably did it right. If you got 79.74 for chlorine, that would be fine if you're a few tenths, off, as long as you get something close. But that's the way of checking our work. So next problem was the percent composition of each element in H2SO4. That's sulfuric acid. First, I'm going to find the molar mass. It's made up of hydrogen. It's made up of sulfur and oxygen. Hydrogen, I have 2 of those. I'm going to multiply it by its molar mass. Sulfur, I have 1 atom times its molar mass. Oxygen, I got 4 of those times its molar mass. So first I look up hydrogen's mass. I find it's 1.008. That's going to be 1.01. Sulfur, I'll look up its atomic mass or molar mass. Sulfur is right here, it's 32.066, which is 32.07 to 2 decimal places. Then oxygen is 16.00. Then I'm going to multiply those. 2 times 1.01 is 2.02. Sulfur, 1 times 32.07 is going to be 32.07. And 4 times 16 it's going to be 64.00. I add all those up, and the total molar mass will be 2.02 plus 32.07 plus 64.00 equals 98.09. And remember, the units would be grams per mole, because 1 mole of sulfuric acid would weigh 98.09 grams. Okay, now I'm going to take each individual mass, divide it by the total. So if I'm talking about hydrogen, that would be, if I separate this, that would be for hydrogen 2.02 divided by the total, which would be 98.09. Multiply it by 100 to get a percent. For sulfur, it's 32.07 divided by the total molar mass, 98.09, times 100. And then for oxygen, it brought in 64.00 grams divided by the total, 98.09, times 100. So first for hydrogen, it's 2.02 divided by 98.09, then multiply that by 100. This equals 2.059, which would be two decimal places would be 2.06, and that's percent hydrogen. For the sulfur, be 32.07. Divide that by 98.09. Multiply by 100. That's 32.694, which would be 32.69. that would be percent sulfur. And then last for the oxygen, 64 divided by 98.09 equals that, multiply it by 100 to get a percent, and you get 65.25. That's how it would round. That'd be percent oxygen. And that should be my answers right there. I'm going to add those up to see if they equal 100 to check my work. 2.06 plus 32.69 plus 65.25. That equals exactly 100. So these answers more likely would be correct. Like I said, if you got something like 99.5, 99.6, or 100.5, that would be close enough. You just rounded a little differently than I did. So our then you look at the next page, the next problem. What is the percent composition of each element in calcium hydroxide? That is Ca parentheses OH with 2 on the outside. And you have to be careful about counting your atoms. Know that this 2 goes with everything inside the parentheses. You got 1 oxygen, you got 1 hydrogen, but then multiply by that 2 on the outside. But it doesn't go with the calcium because the calcium is not in the parentheses. So this is made up of calcium. I have 1 calcium atom multiplied by its molar mass. Oxygen, I have 2 of those multiplied by its atomic mass or molar mass. Then I have hydrogen, I have 2 of those. So, the numbers on the inside multiplied by the numbers on the outside. So then I look on a periodic table. I want to find calcium. Calcium has a atomic mass of 40.078, so that'd be 40.08. Oxygen is 16.00, and then hydrogen is 1.01. So I multiply these out. 1 times 40.08 is 40.08. 2 times 16 is 32.00. And 2 times 1.01 is 2.02. I'm going to add all these up to get my molar mass. So that's 40.08 plus 32.00 plus 2.02. It equals 74.1, but I'm going to go 2 decimal places, so I'm going to say that's 74.10. And that would be grams per mole if I was looking at just molar mass. So now I want to look and find the percent composition. We'll take the part and divide it by the whole. So for calcium, it's going to be 40.08 divided by the total, 74.10. Multiply it by 100 to get a percent. For the oxygen, it's going to be 32.00 divided by the total, which is 74.10. Multiply that by 100. And then for hydrogen, 2.02 divided by 74.10, multiplied by 100 to get a percent. And I'll do the math. First for calcium, that's 40.08 divided by 74.1 and multiply that by 100. That gives me 54.089, so that would round to 54.09, and that would be percent calcium. Next, I'm going to do it for oxygen. That is 32.00 23.00 divided by 74.1. I'm going to multiply that by 100, and that is 43.18% oxygen. And then last, for hydrogen, I'm going to take 2.02 divided by 74.1, and then multiply that by 100, and I get 2.726, which is around 2.73. And that's percent hydrogen, 2.73. That should be my answers. If I did my math right, the way I could check that, just add them up. So this compound is made up of 54.09% calcium, 43.18% oxygen, 2.73% hydrogen. I'm going to check that. 54.09 plus 43.18 plus 2.73. That equals exactly 100. So more likely I did these right, and that's my correct answers. So if I look at my last problems here, it asks me what's the percent composition of oxygen in Mg3PO42. All right, so it's only asking me for one element. That's what most of these questions are going to be on our tests and stuff. But I would recommend that you work it out for all of them. That way you can check your answer to see if they add up to 100 or close to 100, and then just give the answers for the percent of oxygen. So I'm going to find first I find my molar mass of all these. It's made up of Mg. Now there are 3 atoms of Mg in there, multiplied by its molar mass. It's also made up of phosphorus. Now phosphorus, I have 1 on the inside, multiplied by the 2 on the outside. That would give me 2 atoms of phosphorus. And oxygen, I got 4 on the inside of the parentheses times 2 for a total oxygen. Oxygen would be 8 times its atomic mass. So then I'm going to look it up for magnesium. I look at my periodic table. I find magnesium is 24.305. That would be 24.31. So that's 24.31 equals, and then for phosphorus, I'm going to look at its, and I find it's 30.974, so that'd be 30.97. That's 30.97, and oxygen is 16.00, and so when I look it up, when I do my math for all this, I bring my calculator up, and have 3 times 24.31. That equals 72.93. For phosphorus, that's going to be 2 times 30.97. That equals 61.94. And then last, I have 8 times 16 equals 128. That'd be 0.00. I add all those up to get my molar mass. That would be 72.93 plus 61.94 plus 128. That give me a total of 262.87. And now once I get these totals, I can, so when I'm looking for magnesium, I'm going to take 72.93, divide it by the total, which is 262.87, then multiply it by 100 to get a percent. For the phosphorus, it'll be 61.94 0.94 divided by the total, 262.87. Multiply that by the total. And then last, for the oxygen, I would take 128.00 divided by 262.87 times 100. So first, for magnesium, that would be 72.93 divided by the total, 262.87. That equals that. Now multiply it by 100, get a percent. That would be 27.74. And that is percent magnesium. Next, I find the percent of phosphorus. That would be 61.94 divided by 262.87 equals that. Multiply it by 100 equals 23.56%. That's percent of phosphorus. And then last one, do it for oxygen. That would be 128 divided by 262.87 equals that times 100. That equals 48.693, which would round two decimal places, 48.69%, and that's going to be percent oxygen. Now, that should be my answers if I did my math right, but I want to add them up. And that is 27.74 plus 23.56 plus 48.69. You see that equals 99.99, which is close enough. These answers are probably right. And it asked me for percent oxygen, so my answer would really just be, it just wanted the oxygen would be 48.69% oxygen. And that's how you do these problems right here. Now, on your practice problems, your work, what it asks you in the first part is to find the molar mass of each one of these things. That's all you're doing. The second part, you're finding the percent composition. So in this first, once you find these molar masses at the top, you're going to use them in the bottom. So for this first box down here for hydrogen, in this first box, you want to find the percent hydrogen, show your work. Second box, you want to find your percent sulfur. Third box, find your percent of oxygen. And that's how you're going to do these problems. Remember, number 3, you got a total of 4 H's. Even though one of them separated from the other ones, that would be a total of 4 hydrogens. But that's how you do percent composition problems.